Hello. So what do we do when we have kind of a big composite function or like a double composite function? So when we have like f of g of h of x, how do you think we might handle that? Well, what we're going to do is we're just going to use the normal chain rule, and then that's going to tell us how to do kind of this bigger version of the problem. And so what we're going to do is we're just going to say that all of the inside of this f, we're just going to call u. And so let's write that down. So we're going to say our outside function is equal to f of u. And then our inside function is equal to all of g of h of x. And then just like we've done previously, we can take the derivative of each. So the derivative of my outside is going to be f prime of u. And then the derivative of my inside is equal to, that's given by the chain rule. So this itself is a composite function. And so using the chain rule, that's going to be the derivative of the outside. That's just going to be given by this. That's going to be the derivative of the outside evaluated at the inside multiplied by the derivative of the inside. And then now the derivative of our big composite function is we use the chain rule on all of this. So we take the derivative of the outside evaluated at the inside. So this is going to be f prime of g of h of x times, and then times the derivative of the inside. So times g prime of h of x times h prime of x. Great. And so I just have that rewritten here. And so we can kind of think, like when we're doing the chain rule on, kind of a big version of this, we kind of work outward inward. So we do f prime of like all of what's inside times kind of g prime of like the innermost thing times the derivative of the innermost thing. And then as we just showed, this comes from like the normal chain rule.